Hi, boys and girls. Welcome back to the drive-thru. Sponsored as always by the deli. Hungry? Stop by the deli and get yourself a Otis Spunkelmeyer chocolate chip cookie muffin. Chocolate chip muffin, not cookie muffin. Although I'm intrigued by cookie muffins, and I might consider trying to make one sometime. Okay, this is 7-2. You got two new theorems, only one of which, will be our final shortcut to proving triangles congruent. So this is like a throwback Thursday, and it is Thursday today, isn't it? All right, so you're going to think, like, why didn't we learn these things in the triangle chapter, which I think was chapter 3. You know, that chapter where we learned about SAS and SSS and ASA and HL and all those shortcuts. Remember that? Okay. Well, the reason why we haven't learned these yet is that these theorems are based on the triangle sum theorem. They're based on the fact that the sum of the angles of a triangle are 180. And even though many of you came into this class already understanding that principle to be true, we just made it official yesterday. So that's why we're only learning it now. Okay? All right, so the first theorem has a name. It's called the no-choice theorem. And it just says, if two angles from your triangle are congruent to two angles from my triangle, so if you had an angle X and an angle Y, and I had an angle X and an angle Y, well, what would be the measure of my third angle? And don't tell me Z. Good. So either 180 minus parentheses X plus Y, and we'll do that. That's fine. 180 minus X plus Y. Do you guys agree that would be that angle? And what would this angle be? 180 minus, X plus Y. And there, we just proved it. That's the whole proof. Does that make sense? That's a total obvious theorem. What isn't so obvious is that it actually leads us to another shortcut. So I will take more time walking you through the angle side theorem. So, a lot of words here. A lot of words. Okay? If there exists a correspondence between the vertices of two triangles such that two angles of the non-included side are congruent to the corresponding parts of the other, then the triangles are congruent. Okay, let me just first, honestly, I don't even know that you should write that down, unless that is meaningful to you. So you might just want to write angle side theorem, and then put in parentheses AAS, because that's how you're going to write it as a reason. And then you'll just say if you see how that's angle side now? All right? And let me give it some letters. So if you know that, then what do you know? You do know that B and Y are congruent, okay? But this theorem tells you that you actually know more than that. What do you know? That's right. But hold that thought, Grace, because that's going to be how we prove this. Okay? That's what the AAS formula is. Now, Grace had a great thought. She said, if angle A is congruent to angle X, and angle C is congruent to angle Z, then what must be true about angle B in relation to angle Y? They must be congruent to each other, right? So we could get that as our next step by the no-choice theorem. And now what do we have? Just cover up angle A and angle X, and what do you have? They're congruent triangles by what? ASA. So AAS is actually just another way to do ASA. I don't know if you can follow that or not. Meaning, if I had AAS, I would just be one step away from proving it with ASA. Do you follow that? So rather than take that step every single time, we just take out the need to do that no-choice theorem, and we prove one more shortcut to prove triangles congruent. That's it. That's all we're learning today. Honestly, you should feel like you've gone back in time. Now, ASS does not work, and it will never work. And hopefully, before we take the air test, I'll be able to explain that to you. But that's not that big of a deal. I promise before the end of the year, you will understand why ASS doesn't work. Okay? Can I get a boom? Thank you.